All right, enlargement. This says a transformation in which the object is expanded or reduced onto the image from a fixed point called the center of enlargement. So what is an enlargement? An enlargement is a transformation in which the object is expanded or reduced onto the image from a fixed point called the center of enlargement. So in an enlargement, the image can either become bigger than the object or the image can become smaller than the object. All right, in this diagram, we're going to do some enlargement. All right, I'm just sort of testing what type of enlargement I can do. So let me say 2, 2, 2. No, this is not going to work. All right, so here's what we're going to do. I'm going to do an enlargement with a scale factor of 2. I'm going to try and do an enlargement with a scale factor of a half, and I'm going to try and do an enlargement with a scale factor of -1. All right, let me just look at the picture. All right, so no, what they did was 2 minus a half and -1. So let us do the same. All right, now I'm going to do here an enlargement with a scale factor of 2. And the center of enlargement is going to be the origin. Now, here's how I'm going to do that enlargement. I'm going to use the fact that in an enlargement, the distance from the center to the image is k times the distance from the center to the object. I'm going to use the fact that in an enlargement, the distance from the center to the object is k times the distance from the center to the image. Now, I'm using a scale factor. The scale factor is k. I'm going to use a scale factor of 2. Now, to get to B from the center, I had to go 2 right and 2 up. So 2 right I had to go 2 right and 2 up. Now, to get to the image now, what I'm going to do, I'm going to double that distance. So I'm using the fact again that the distance from the center to the image is k times the distance from the center to the object. So if I double this, it's going to become 4 right and 4 up. From the center to B is 2 right, 2 up. If I double that, I'm going to go 4 right and 4 up. This would be the new position of B. This would be B prime. From the center to C, I had to go 4 right and 2 up. To get to the image, I must double that distance. So it's 8 right, 1, 2, 3, 4, 5, 6, 7, 8, and 4 up, 1, 2, 3, 4. This is the new position of C. This is C prime. To get to A from the center, it is 2 right and 1, 2, 3, 4, 5, 6 up. To get to the image, A prime, I must double that distance. So it's 4 right and 12 up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This would be the new position of A. This is A prime. Now, to complete my figure, all I need to do is to what? Use a ruler and a pencil to connect the vertices. Use a ruler and a pencil to connect the vertices. This is the object, and this is the image. and K, the scale factor, is equal to 2. K, the scale factor, is equal to 2. All right, I need all of you to do the same with your diagram. All right, so the next thing we're going to do now is we're going to do an enlargement. We're going to do an enlargement, center the origin, and sometimes this thing just behave like it hates me. I'm trying to erase something. So I'm going to now do an enlargement, center the origin, and scale factor minus a half. Now, when the scale factor is negative, when the scale factor is negative, the object and the image would be on opposite sides of the center of enlargement. All right, so this is what I'm going to say now. To get from let us say from A to B, from B, the center to B, you're going to go 2 right. To get to B from the center, you would go 2 right and 2 up. Now, what I'm going to do now, to get to, if the scale factor is negative a half, I'm going to have to half the distance. When the scale factor was 2, we multiplied the distance by 2. When the scale factor is a half, we're going to half the distance. But because the scale factor is negative, you are now going to have to go in the opposite direction. So instead of going 2 right, you would have to go left. Instead of going 2 up, you would have to go down. Now, if the scale factor is negative a half of 1, so now I'm going to have to go 1 left, 1 left, 1 left, and 1 down. I'm going to go 1 left and 1 down to get to the image. So 1 left and 1 down would put me here. This is B double prime. Now, to get to the C from the center, I would go 4 right and 2 up. When the scale factor is negative a half, the distance is going to be a half and the direction going to have the opposite direction. So this is going to be 2 left and 1 down. So to get to the image, I have to go 2 left and 1 down. This would be the new position of C. This is C double prime. Lastly, to get to A from the center, I would go 2 right, 2 right, and 6 up. Now, to get to the image, when K is negative a half, I must go what? Half the distance and go in the opposite direction. So it's 1 left and 3 down. So I'm going to go 1 left and 3 down. This is the new position of A. This is A double prime. All right. Now, this is another image. This is another image where K here is equal to minus a half. So, points to note, when K is negative, the object and the image are going to be on opposite sides of the center of enlargement. If K is more than 1, for example, when K is 2, the image is larger than the object. When K is less than 1, for example, if K is a half, the image is smaller than the object. So those are just points to note. All right, so right now I want you guys now to do the same enlargement, or we could say reduction. All right, so we're going to complete this diagram now by doing one more enlargement, where this time the scale factor is going to be -1. Now, first of all, once the scale factor is negative, it means that you must be going in the opposite direction. That's the first thing. Whatever is the distance from the center to the object, to get to the image, you must go in the opposite direction. But this time, because the scale factor is 1, the distance from the center to the image is the same as the distance from the center to the object. And because the scale factor is negative, the direction must be the opposite direction. So to get to B from the center, we'd have to go 2 right and 2 up. To get to B triple prime, I'm going to go 2 left and 2 down. 2 because the scale factor, the distance is the same because the scale factor is 1. The direction is negative because the direction is opposite because the scale factor is negative. So -2, 2 left and 2 down would put me here, the new position of B. This would be B triple prime. Now, from the center to C, it's 4 right and 2 up. Now, to get to the image, I have to go 4 left and 2 down. So the distance is the same because the scale factor is 1. The direction is is opposite because the scale factor is negative. So I have to go 4 left and 2 down. This would be the new position of C. This is C triple prime. Lastly, to get to A from the center, you'd have to go 2 right and 6 up. To get to the image, A triple prime, I'd have to go 2 left, 2 left, and 6 down. The distance is the same because K is 1. The direction is opposite because K is negative. So 2 left and 6 down. This is the new position of A. This is A triple prime. All right.
Sir, isn't it 4 down?
To what?
Why? Why? Yes, A triple prime.
No,
Yes.
6 down. To get to A from the center, it's what? 1, 1, 2 right, and 1, 2, 3, 4,
Okay.
5, 6
5,
up.
6.
So you have to go 2 left and 6 down.
6 up. Oh, all right, sir. Thanks.
All right. All right. So here, this is where it's an image, and K here is equal to -1. All right. Just one last thing I want to point out to you. A line connecting corresponding points on the object and image must pass through the center of enlargement. It's something I want to point out to you. If I line up all the B's, I should be able to draw a straight line through all the B's, and that straight line must pass through the center of enlargement. So a line through all the B's, corresponding points on the object and the image must pass through the center of enlargement. I could do the same thing for the C's. I could do the same thing for the C's. See there? A line through corresponding points on the object and the image must pass through the center of enlargement. In fact, this is a very good way to find out, this is the principle that we use to determine the center of enlargement when it is not known. All right, let's see what the next page has on it. Oh, sorry, let's go back. All right, so let's see if there's anything down here. All right, yes, here are some features. Some of them we already started discussing, but here are some features. Feature 1, the lengths of sides of images are the lengths of sides of image are k times the length of the sides of the object. So here this is saying that what? The scale factor k is equal to the length of one side on the image divided by the length of corresponding side on the object. So all that this is saying is that k would be equal to, let's say, a prime, b prime divided by ab. Now, if I cross multiply, I'm going to get a prime, b prime is equal to k multiplied by ab. So in other words, the lengths of the sides of the image are k times the length of the side of the object. AB is the what? Is a side on the object. A prime, B prime is a side on the image. So the length of A prime, B prime is k multiplied by the length of this corresponding side on the object. Please note, the scale factor k is equal to the length of one side on the image divided by the length of the corresponding side of the object. All right, let's look at some further observations. All right, all right, so in a sense, that is just showing, you can see for yourself, it's just showing what I just said, that A prime, B prime is equal to k multiplied by AB, or A prime, C prime is equal to k multiplied by AC, or B prime, C prime is equal to k multiplied by BC. In other words, the length of a side on the image is equal to k multiplied by the length of the corresponding side on the object. All right, this is sort of like the completed diagram of what we did on the page before. All right, I'm getting some interference in it, so I'm trying to get it out. All right, here is like the completed one. All right, and you can see when k is what? Greater than 2, the image is larger than the object. When k is less than 2, less than 1, the image is smaller than the object. When k is equal to 1, the object and the image have the same size. So observation 2, the distance from the center of enlargement to the image is equal to k times the distance from the center to the object. All right, so all that this is saying is that k is equal to O A prime, which is the distance from the center to the image, divided by OA, which is the distance from the center to the object. If I cross multiply, I'm going to get I'm going to get A prime is equal to K multiplied by OA. And all that this is saying, the distance from the center to the image is equal to K multiplied by the distance from the center to the object. And this is the principle that we use in order to do the enlargement in the first place. Other observations. If K is positive, the object and image are on the same side of the center of enlargement. So when K is positive, when K was positive 2, the object and the image was on the same side of the center of enlargement. When K is negative, the object and image are on opposite sides of the center of enlargement. What else? If K is greater than 1, the image is larger than the object. If K is less than 1, the image is smaller than the object. If K is equal to 1, the image and the object are the same size. What else? 5. The area of the image is equal to K squared times the area of the object. This is saying that K squared is equal to area K squared is equal to area of image divided by area of object. So if you cross multiply, you're going to get area of image is equal to K squared times area of object. All right, and it's written right here. So K squared is equal to the area of the image divided by the area of the object. The area of the image is equal to K squared times the area of the object. That is observation 5. Now we can talk about locating the center of enlargement. All right, or we'll do this in the next video. I don't want this video to be too long.